Welcome students. Previously Form 3, we were dealing with topic 2. Under lesson 7, we were dealing with the molecular formula. Today lesson 8, we are dealing molar solutions. What is a molar solution? A molar solution is a solution that contains 1 mole of a solute in a liter of a solution. That's how you define a molar solution. So in this molar solution, or in this section, the term concentration, molarity, and dilution of solutions will be discussed. So number 1, we're starting with concentration of a solution. So concentration of a solution is the amount of a solute contained in a given volume of a solution. That's the definition for concentration of a solution. And we are told concentration of a solution is expressed in 2 ways. The first way is grams per liter, which is written by gram per liter, like that. Or, which you can say, gram per decimeter cube. It will be one and the same. So, or it can be expressed by moles per liter, or moles per decimeter cube. So you can say mole per decimeter cube. Those are the 2 ways that we can express concentration of a solution. So thereafter, we are going to go to examples. Example 1. We are told 4.0 grams of sodium hydroxide is dissolved in 200 centimeter cube, then made up to 250 centimeter cube of solution. Full stop. Calculate the concentration of sodium hydroxide in A, gram per liter, which we have said gram per decimeter cube. In part B, we have moles per liter or moles per decimeter cube. They are just one and the same. So if you are told calculate the concentration in gram per liter or gram per decimeter cube, you are supposed to know first of all what mass of solute do you have. Because if you check up there, we are having this is the amount of solute contained in a given volume of a solution. So in our case, I'm having 4.0 grams of sodium hydroxide. So I said 4.0 grams of sodium hydroxide. What volume has it been dissolved? So here we're having 250 centimeter cube of solution. Learners, this 200 is only for just dissolving, but they have made up to 250 centimeter cube of volume. So that means it has been dissolved in 250 centimeter cube. So you ask yourself, what about 1 liter? That's 1000 centimeter cube, because you are told gram per liter. So this mass has been dissolved in 250 centimeter cube. But what about 1 liter? So if you convert liter into centimeter, it will be 1000 centimeter cube. So you cross multiply, you're going to have 4.0 times 1000 over 250. So here we are going to get 16. So the unit for that concentration is gram per liter. Gram per liter. Or you can write 16 gram per liter, like that, gram per liter. Okay, but B, we are told moles per liter. You are supposed to get this concentration of sodium hydroxide solution in moles per liter. So this we can do it in 2 ways. The first way, we are supposed to first of all get the moles. We have to get the moles using the information given here. We are given 4.0 grams. So how do you get moles? Moles is given by mass over molar mass. So in our case, we are dealing with RFM because we are given sodium hydroxide. So let's get RFM of sodium hydroxide. So sodium alone is 23 plus 16 plus 1 for hydrogen. This will give us 40. So that means moles will be given 4.0 as the mass of the sodium hydroxide divided by 40, which is the molar mass, or it is RFM. This will be 0.1 moles. So there we are going to say what amount of solvent or water has it been dissolved. That means this 0.1 moles has been dissolved in 250 centimeter cube of solution. So it has been dissolved in 250 centimeter cube of solution. So we ask ourselves, what about 1000 centimeter cube? What about 1000 centimeter cube? So in our case, we are going to say 0.1 times 1000 divided by 250. So here we are going to get 0.4 moles per liter. That's what we are going to get. So that's the first way that we can get that concentration of sodium hydroxide in moles per liter. Or if you don't want to use like that, we can get alternatively or another method 2. In our case here, we can use our concentration or moles in moles per liter. Concentration in moles per liter can be given. Let's say concentration in moles per liter can be gotten by concentration in gram per liter over the RFM. So check, initially we have gotten our concentration in gram per liter as 16 divided by the RFM, which is 40. What are we going to get? We are going to get still 0.4 moles per liter. That's the way that you can get your concentration in moles per liter or moles per centimeter cube. So we are done with that concentration of a solution. We are going to go next, molarity of a solution. So we are told, unlike concentration, molarity is only given in moles or is only expressed in moles of the solute per liter of solution. This is normally expressed in mole per centimeter cube or mole per liter. So what we are saying is, if you remember, we said concentration is expressed in two ways. One way is gram per liter, the other way is moles per liter. That means moles per liter is just, in other words, mean molarity of a solution. So if you are told express or if you are told calculate the concentration of sodium hydroxide in moles per liter, they are just asking calculate or determine the molarity of sodium hydroxide. That's what we mean. So let's go examples or calculations concerning molarity of a solution. The first example, we are told 71 grams of sodium sulfate are dissolved in enough water, then made up to 1 liter of solution. Full stop. We are told determine the molarity of the solution formed. So in bracket, we are given sodium 23, sulfur 32, oxygen 16. Okay. So we have several formulas for calculating molarity, but check here, you are given the mass of the potassium sulfate, but it has been dissolved in 1 liter of solution. So if you see your mass and it has been dissolved in a liter of a solution, the correct or the best formula will be the one that we are going to have here. Molarity will be equal to mass in gram per liter, over RFM. So mass in gram per liter is also called concentration in gram per liter. So in our case here, we have 71 gram per liter already as our mass in gram per liter. What about the RFM? So we are going to get RFM of potassium, sodium sulfate. So sodium is 23 times 2 of sodium plus 1 for sulfur plus 16 times 4 of oxygen. Here we are going to get 142. Okay, so we are going to say molarity will be equal to mass in gram per liter, which is 71, divided by the RFM, which is 142. So this will be equal to 0.5 mole per liter. Mole per liter, which you can just write M capital letter. When you write M capital letter, that means molarity, 0.5 mole per liter, or the molarity. Okay, number 2, we are told when 34.8 grams of potassium sulfate were dissolved in 500 centimeter cube distilled water, calculate the concentration of potassium sulfate in grams per liter. So they're asking us concentration in gram per liter. So we are going to say, what is your mass of the solute? The mass of the solute is 34.8 grams. So we say 34.8 grams, what volume of solution has it been dissolved? 500 centimeter cube. Okay, 500 centimeter cube of distilled water. So we ask us, what about 1 liter? That means what about 1,000 centimeter cube? So we are going to say 34.8 times 1,000 divided by 500. So here we are going to have 69.6 grams per liter. That's what we are going to have. Okay, that's in our concentration in gram per liter. So from your B, we are told the molarity of the solution. So here already we have gotten concentration in gram per liter. We are going to use the formula for calculating the molarity, as molarity is given by concentration in gram per liter over the RFM. So we have to get first of all RFM of potassium sulfate, K2SO4. Potassium is 39 given here, times 2 plus sulfur 32 plus 16 for oxygen times 4. This one we are going to get 174. We are going to get 174. So that means using the formula for calculating molarity will be concentration in gram per liter over the RFM. So in our case, our concentration is 69.6 gram per liter over the RFM, which is 174. Here we are going to get 0.4 mole as our molarity. So we are going to have 0.4 M capital letter. So concentration in gram per liter is also called mass in gram per liter. You have to know that. Then number 3, we are going to go, we are told determine the molarity of a solution containing determine the molarity of a solution containing 5.3 grams of sodium chloride. Here we are missing the word containing. We just use containing 5.3 grams of sodium carbonate dissolved in 250 centimeter cube of distilled water. So as we have said earlier on, we are having several formulas for calculating molarity. The first way was molarity is given by mass in gram per liter. So here this mass, it has not been dissolved in 1 liter of a solution. So you can dissolve it in 1 liter of a solution. The formula will be molarity is given by concentration or mass in gram per liter over the RFM. But if you're having mass and you're having your volume, which is not 1 liter, we can have another formula, and that formula will be molarity will be equal to moles times 1000 over the RFM. So let's start with getting first of all RFM of sodium carbonate. So sodium 423 times 2 of sodium plus carbon 412 times 16 times 3 for oxygen, that's 106 as sodium carbonate, the RFM of sodium carbonate. So we are going to start by looking for moles. Moles is given by mass over molar mass. Mass over molar mass, or RFM. So our mass given here is 5.3 divided by 106. So here we are going to get 0.05 moles. Okay. Thereafter, we can write our formula for molarity. Molarity is equal to moles, which we have gotten now, times 1000 over volume used. Okay, if we take our values and we substitute, molarity will be equal to moles, which is 0.05. We have gotten now multiplied by 1000, which is in the formula, divided by volume used. The volume that we have is 250 centimeter cube. So here we are going to get 0.2 M. 0.2 mole as our molarity. So that's the best method to use when you have mass in gram but it does not dissolve in 1 liter. Or else you can use your old formula, which is molarity is given by concentration in gram per liter over the RFM, method 2. So we are going to start with, say, 5.3 gram of this sodium carbonate is dissolved in 250 centimeter cube of distilled water. So we ask us, what about 1000 or 1 liter? So here we are going to say 5.3 times 1000 over 250. So here we are going to get 21.2 gram per liter. So next we are going to have our molarity. Molarity will be equal to concentration in gram per liter over the RFM. So this will be equal to concentration in gram per liter is 21.2 divided by the RFM, which we have gotten here as 106. So in doing so, we are going to get still 0.2 mole. Okay, 21.2 divided by 106. Okay, good. So that's the other way that you can get. Next, we are going to proceed. We are going to question number 4. Question number 4, we are told calculate the number of moles of sodium carbonate present in 100 centimeter cube of 2 mole sodium carbonate solution. So here we are told to look for the number of moles. So we have the formula for calculating molarity, and that formula was molarity is equal to moles times 1000 over volume used. So if you want to look for moles, the formula will be moles will be equal to molarity molarity times volume used over 1000. This will be how the formula will look like. Okay, so here we are going to say straight moles is given by molarity times volume used over 1000. So in our case, our molarity is 2 mole. That's 2 mole. 2 times our volume used in our case is 100 centimeter cube. So divided by 1000, which is in the formula. Here we are going to get 0.2 moles. That will be our formula. So number 5, we are told calculate the mass of sulfuric 6 acid in 250 centimeter cube of a solution whose concentration is 0.25 mole per centimeter cube. What have we said, mole per centimeter cube, or concentration which is expressed in mole per centimeter cube? That's just the molarity. So they're asking us the mass. So if we want to get the mass, we have to get first of all moles. When I get the moles, that's the time that I can get mass, because I have the formula for mass will be equal to moles times RFM. Okay, I start by calculating moles. Moles is gotten by molarity times volume used over 1000. So our molarity in our case is 0.25 times our volume used is 250 centimeter cube divided by 1000. So here we are going to get 0.0625 moles. Okay, if we have our moles like that, then that means we can get the mass, because mass is given by moles times RFM. So let's look for the RFM of sulfuric 6 acid, H2SO4. 1 times 2 for hydrogen plus 32 for sulfur, 16 times 4 for oxygen. We are going to get 98. So that means the moles I've gotten as 0.0625 here times the RFM, which I've gotten 98. So this one I'm going to get 6.125 gram. That's the mass of sulfuric 6 acid in 250 centimeter cube of solution whose concentration is 0.25 moles per centimeter cube, or moles per liter. That's how we are going to calculate the mass. First of all, you have to get the moles, then thereafter you get the mass, because mass is given by moles times RFM. Okay, after that, we are going to go to question 6 and question 7, but they are in the extended question. We're stopping there.